Hi students, this is Mr. Yao. In this lesson, we're going to learn more about triangles, more specifically, triangle median. Here's the definition for a median. A median of a triangle is a segment from a vertex to the midpoint of the opposite side. So here you go, a vertex, then this other point is a midpoint, and you're connecting them. That makes a median. It's different from what we have learned in the previous lesson. The previous lesson, we learned midsegment. And that is to actually connect two midpoints from two different sides, not using any vertex. So median, there are three of them, because of course you have three vertices. And when you connect a vertex with the midpoint on the opposite side and another one, there you go. The three median are concurrent. Here's what this word means. Concurrent means they will go through the same point. They will overlap at the exact same point with the three medians. The point of concurrency has a name. That is called the centroid. The centroid is inside the triangle. Of course, because you're trying to connect with the median, the reason we emphasize on inside the triangle is because, well, even if your triangle is, say, that shape, when you actually try to connect the median, it's still going to be within the triangle. That is the centroid. The point is also called the center of gravity of a triangle because it is the point where a triangle will balance. Here's what it means. Let's say you cut this triangle out from this piece of paper. And let's say it's a very ideal piece of paper. If you use a pencil and actually try to stick onto this point, you should be able to actually balance that triangle. Of course, in an ideal situation without wind and all the other factors. So that's what the special thing about a median, about the centroid. Now let's talk about the relationship with segments that's being cut by the median, or the centroid. Concurrency of medians theorem. The medians of a triangle intersect at a point, and again, this point is the concurrency, the point of concurrency, which is also called the centroid. That is 2/3 of the distance from each vertex to the midpoint of the opposite side. So here you go. AP is 2/3 of AE. AP is 2/3 of AE. Then BP is 2/3 of BF. BP is 2/3 of BF. CP is 2/3 of CD. CP is 2/3 of CD. So in other words, the centroid is going to cut each median into two portions. You have this portion, which is a slightly longer portion, and then you also have a slightly shorter portion right here. The relationship between these two portions is 2:1 as a ratio. That's how we have the longer portion compared to the whole being 2/3, or the shorter portion compared to the whole, it's 1/3. If you use the longer portion compared to the shorter portion, it's a 2/1, or if you use the shorter portion compared to the longer portion, that is 1/2. So these are all different ratios that came from this theorem. You're not always going to just focus on 2/3. You could have 1/3, 2, or 1/2, based on how the information is given to you. So now let's see some examples. Example 1. Q is the centroid, so this is enough information to tell you all of these lines are actually medians. Because if Q is the centroid, its vertex connect to the centroid, that means going to the other side, that's going to be the midpoint. So these two portions are the same, these two portions are the same, and these two portions are the same. So it's guaranteed that they're all midpoints. Let's just focus on the median. As Q is 8, is asking for QW. So again, the relationship as Q is 2/3 of the whole thing, but the longer portion and the shorter portion is just a 2/1, which means QW is going to be half of SQ, which is going to be a 4. As for SW, now that we know SQ is 8 and QW is 4, we can just add them together. So 8 plus 4, that is 12. Moving on. CA is 9. Well, you can see all of these are indicating they're all midpoints, which means all of the three lines inside the triangle, they are all medians. ZA is this portion, it's 9, and is asking what is the length of ZC. So typically, instead of finding ZC right away, you can always choose to find the shorter portion first. If ZA is 9, that makes AC 9/2 or 4.5. because it's going to be half of ZA. And then ZC is just going to be ZA plus AC, which is 13.5. That's example 2. Moving on, example 3. M and K are midpoints. So vertex connect to midpoint, vertex connect to midpoint. Of course, these two, VK and XM, they're both going to be median. And that means B is our centroid. VB is X. So this portion is X. BK is -4 plus X. So VB is the longer portion, BK is the shorter portion on the whole median. The relationship is twice. The longer portion is twice of the shorter portion. So that means X is going to be twice. Let me have to use the letter to write. VB is twice of BK. Because VB is the longer section, BK is the shorter section. So X equals twice of -4 plus X. So we have X equals -8 plus 2X. Finish solving. X equals 8. Example 4. D is the centroid, which again means BF, AE, and CG, they're all going to be median. BD is 4X plus 5. And then we are also given BF being 9X. So BD is this longer portion in the whole median, and BF is the whole median. So the relationship is BD is going to be 2/3 of BF. So 4X plus 5 is going to be 9X times the 2/3 because BF is 9X. We have 4X plus 5 being 6X. Finish solving. X is 5/2. So just a reminder again, we're not only focusing on the 2/3. Depending on how the information is presented to you, you could have 2/3, you could have 1/3, you could have 2, you could have 1/2, or you could even have 3/2 and 3. So these are all the possible ratios with the different side length. So you can either have the longer portion, the shorter portion, or the whole thing in comparison. That's the last example, and that's everything for this lesson. Thank you.